Question 5. The graph shows the melting points of elements in period 3 of the periodic table. Phosphorus and chlorine have simple molecular structures, and more information about phosphorus and chlorine is given in the table below. Explain the differences in the melting points of phosphorus and chlorine. Okay, so what you're seeing here is the trend in melting and boiling points going across period 3, and this can be related directly to the type of structures that these elements have got. So obviously here, sodium, magnesium and aluminium, we've got giant metallic lattices at this point, and increasing melting and boiling points due to having more delocalized electrons, resulting in stronger attractions between the electrons and the delocalized electrons and the ions in the structure, needing more energy to overcome them. Obviously, the difference between magnesium and aluminium is only slight, but there is an increase there. Silicon in group 4 has now got a giant covalent structure, so at this point we're trying to overcome or break very strong covalent bonds, hence why the melting point is so high. And then we drop back down to phosphorus, sulfur, chlorine and argon. Here we have our simple covalent lattices, only overcoming intermolecular forces, so London forces in particular. And we can see the fluctuations there due to numbers of electrons, which is always the case with London forces. London forces are only arise due to movement of electrons and even distribution of electrons, resulting in the temporary dipoles and the induced dipoles in a neighbouring molecule. So here we have varying numbers of electrons, which will give us the variations in the melting points. So phosphorus and chlorine have simple molecular structures. It always tells us that. Here we have more information about the chlorine and phosphorus. So we've got the full molecule of each one. So this is the information you probably won't be aware of. So phosphorus, a molecule of phosphorus doesn't exist as a phosphorus atom on its own. It's a molecule of P4. So there's 4 phosphorus atoms all covalently bonded together. And obviously you're aware that chlorine is a diatomic molecule. It's Cl2. So what's happening here? We've only got, per atom, there's only 2 more electrons in chlorine than there is in phosphorus. So on the atomic level, you'd expect the London forces to be very, very similar, probably a little bit higher for chlorine because it's got 2 more electrons. However, because phosphorus has got 4 phosphorus atoms as opposed to 2 chlorine atoms, then the numbers of electrons in phosphorus is significantly higher. So we're going to have significantly well, not significantly, but higher melting and boiling points in the phosphorus because there are more electrons. All right, that is just a standard basic explanation of why we have variations in London forces. Electrons is the only variable present. So in this case, P4 has more electrons than Cl2. That means the stronger London forces in P4, and once again, more energy is needed to overcome them. All right, the same argument repeating itself over and over again, making sure that we have reference to the energy needed to break or overcome the forces.